Hello there, welcome today for another tutorial section on data analysis 1. Let's start quickly. So we have two assumptions that are basic to parametric test and also two assumptions that are basic to non-parametric test. So for the parametric test, we have normality, we have linearity, we have homogeneity of variance, and so on. Okay, so for parametric tests to be able to work and give out accurate results, the normality assumption should hold, homogeneity of variance should also hold, the data should also be linear. Alright, so basically when the data set is normally distributed, it means that when we check how spread out the data looks like, we won't be seeing very large outliers. Also, they will be hovering around the average of the data set. Alright, so for parametric tests to also give out accurate or valid results, it's very important for it to be normally distributed, like t-test and ANOVA. Okay, and for the homogeneity of variance, so the variances of the dependent variables should roughly be equal across. Okay, so we remember in Minitab lessons, in SPSS lessons, we do a test called the Levene test, which checks the homogeneity of variance before we can proceed with our respective analysis. Alright, so this ensures that difference detected are due to the group means and not the differences in variables. Alright, so having two assumptions for the parametric, we also have two assumptions that are basic to the non-parametric techniques we use in our daily analysis. So for the non-parametric, we have independence. Okay, so the data points you are dealing with are independent of each other. The occurrence of one does not have effect on the other, basically. And also, the data points we normally work with are expected to be ordinal. So when we say ordinal, it can be ranked, or we can arrange them from the lowest to the highest. Alright, so non-parametric tests like the Mann-Whitney, the Kruskal-Wallis are normally designed to use ranked data points in the analysis. So rewinding on these two basic assumptions for non-parametric and parametric. For parametric, we have normality and homogeneity of variance and linearity. And also non-parametric, we have independence and then measurement level, normally ordinal. Okay, all right, so we move on. Two uses of descriptive statistics. Continuing with question 3, state two uses of descriptive statistics. So we have descriptive statistics and inferential statistics. So considering descriptive statistics, we use descriptives to summarize the data. Okay, we also use it in visualizing and interpreting. Okay, basic interpretation. So we use the central tendencies, the spread, okay, to summarize the data, basically the mean, the median, the mode, standard deviation, to describe the central tendency and spread of the data set. And for visualization, we graph, we use tables, we use frequency distributions to help interpret the trend we see, the patterns, if there are any, okay, and variability for quick understanding before the inferential statistics. So discrete statistics is very, very essential because if we don't know how our data set appears or how they 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 coordinate with each other, we cannot build correct or accurate inference from the data. So we need to first explore the data, see how it runs through, how it's spread out, okay, before we can build inferences on the data set. Question 4. Processes involved in data screening and cleaning. Okay, so data wrangling, screening, cleaning is a vital role in data analysis. Before you can work well, okay, analyze your data and get correct input, data cleaning is the first and important step to do. Okay, so to be able to screen and clean your data very well, you have to, one, check for missing data. Okay, so you have your data in Excel, you can easily check for missing data using some Excel formulae, right? When it is also in Python, you can load your data and check for missing values. So the first step is to check for missing data. You have to identify missing entries and decide whether those missing cells or missing data, you can input them, or are you forced to remove the entire row having the missing space, right? So it depends on the analysis you are doing and what you aim to achieve. Sometimes it is good to input them. Sometimes it's best to just clear the entire row containing the missing data point. So it's always with respect to the kind of analysis you are doing. Because sometimes when you have a time series analysis like that and the date timestamp follows, taking them out will obviously bring some loopholes in your data time. Okay, so maybe you have recorded some kind of data points over an hour in which every minute you receive a data. So in case your recording device malfunctions and you are not able to record some data within some minutes, taking that data out will create a loophole which will break the consistency you have in your data set, as in every minute you are getting a data point every minute. So in such cases, inputting them is better, right? So you can read on how or the conditions you have to look out when you are inputting the data yourself. 2, you have to identify and also handle the outliers in your data. So detect extreme values that may distort results and treat them appropriately. All right. 3, validating the data entry. You have to check for input errors, you have to check for duplicates, and also check for inconsistencies. 4, ensuring variable consistency. So make sure variables follow correct format, unit, and coding rules. Okay, if you have unit in your dataset, make sure it runs through correctly. You have to basically check every single data point if it conforms to the general data appearance. Okay, question 5. Define the following terms: codebook and then data file. I think we came across codebook in our previous section and it's not new to us. So a codebook is a document that describes each variable in a dataset, including its name, its label, possible values, then the coding scheme. That is, you have male to be 1, females to be 2, like what we did earlier, and then the measurement scale or the measuring scale. So that's basically a code book. It's a document that contains all the things you've done, all the changes you've done to your data, all the coding scheme you applied, all right, the labels, and the possible values. And a data file is a computer file containing the processed or the raw data in a structured format. So example, Excel files containing our data is a data file, CSV is a data file, SPSS, okay, .sav. When you have a file like that, it's a data file. And that particular file is ready for data analysis. Okay. Question 6. We have examples of statistical techniques for exploring the relationship between two or more variables. You want to explore the relationship between two or more variables. How variable A relates with variable B. So we can use correlation, right? Correlation coefficient to determine the relationship between two variables. Okay. Also, we can use multiple regression to determine how two variables, three variables, four variables, and so on relate with each other. So Pearson correlation or Spearman correlation, okay, measures the strength and direction of a linear relationship between two continuous variables, or measures the relationship between two continuous variables. And then multiple regression analysis to predict the value of a dependent variable based on two or more independent variables. So with that, we can know the influence each independent variable has on the dependent variable, and also that includes the relationship between two or more variables. Are you okay? We move on to question 7. So question 7 says that we should list examples of statistical techniques for exploring differences among groups of variables. The first one was exploring the relationship between two or more variables. This time around, we want to know if there is this difference among groups of variables. So remember, independent sample t-test compares means of two independent groups. We have one-way ANOVA, two-way ANOVA, all right? So one-way ANOVA independent sample t-test tests if there is what difference between groups or among groups, okay? All right, so that's for the first part of our questions. We move on to the second part. We continue with the section B. So we were provided with an output, okay, and based on the output, you are supposed to answer some questions under that. So 1, comment on the distribution of figure 1. So in figure 1, we saw a histogram with the normality plot, okay, we had a box plot underneath and also a confidence interval diagram over there with an output on the right hand side. So comment on the distribution of figure 1. So the distribution of figure 1 is exhibited by the histogram and the normal plot, okay, and we had some output where we have the Anderson-Darling normality test, which shows that the A squared is equal to 2.04. That's the Anderson-Darling normality test, and the p-value for that was less than 0.005. So this indicates that the data is significantly deviating from the normal distribution. So you can basically state our hypothesis that H0, it is what normally distributed, and H1 not normally distributed. Okay, and if the p-value is less than 0.005, so what do? We reject the null hypothesis. So if you reject the null hypothesis, we conclude that the data set is what is not normally distributed. Okay, so looking at the other metrics given at the right hand side, we saw skewness to be 0.7866. We saw ketosis to be negative 0.2836. Okay, it tells a lot about our data in which you are working with. So for the skewness 0.7866, it's moderately positive skewed. Okay, so it means that the long tail will be found at the right hand side. And the ketosis value of negative 0.2836 it is slightly platycetic, okay, which means that the normal line with the histogram is a bit flatter, unlike the normal curve we plot. Question 2. Comment on the measures of dispersion. So for the measures of dispersion, we have standard deviation there, we have variance there, we have the range, we have the interquartile range, and we have the confidence interval for the standard deviation. Okay, so looking at the standard deviation value of 6.42, variance value of 41.242, the small value of the standard deviation indicates that there's what little or moderate spread around the mean value. Okay, and the range too, we had 37 as a maximum, we had 10 as a minimum. So you can see that there's a wide range between the smallest and the largest value. Okay, 37 and 10. In the interquartile range, also we have the value to be 8.750 when you do the subtraction uh, from the first quartile and the second quartile. Okay, so the third quartile. So looking at the difference between the first quartile and the third quartile, we have 8.750. So it also shows that the 50% of the data has a narrow spread compared to the entire range. Okay, and then the confidence interval for the standard deviation too falls within the interval, which confirms that there was a less variability or moderate variability in the data set. Question 3. Comment on the measures of central tendency. So with the central tendency section, we have the mean, we have the median. Okay, the mean value was 21.265, the median was 20. And the median's 95% confidence interval was between 17 and 21, which can be found where you can see 20 in there. Okay, so it's slightly lower and narrower than that of the mean, reflecting median's robustness to skewness. So that is for the comments. Question 4. So which test was employed to verify the distribution of figure 1? So when you look at the figure 1, you see the Anderson-Darling normality test. So that was a test employed to verify the distribution. Okay. And question 5 says, is the test in A significant? So we saw that the p-value was less than 0.005. So it was significant. Are we okay? Everything you need to answer the question is found on the figure provided. So you just look at it and you write something. Question 6, we are explaining why we are saying that it is statistically significant. We said that it is not normally distributed, so we are proving why. So as I talked about that, you state your hypothesis H naught, okay, such that we have data is not normally distributed. And then we have H1 such that data is normally distributed. So we can have H naught, data is normally distributed. H1 is not normally distributed. So when you have our hypothesis stated, then we always look at the p-value, okay, to make our conclusions. So p-value was less than 0.005. So if the p-value is less than 0.005, it means that we are going to reject H naught with confidence of 95%, all right? So reject H naught and say that the data is what? Not normally distributed. As simple as ABC. Okay. We move on to our next question. What other names can we give to the term respondent? Respondent. So respondent, we normally use that in our research work, talking about those who answered our questionnaires. All right. So we can call respondent participant. Okay. What do you also think? Subject. In case our questionnaire was in the form of interview, we can say interviewee. You can write the spelling. All right. So these are names you can call respondent, participant, subject, interviewee, in case your research work was in the form of interview. All right. The follow-up question is, explain the use of the variable or factor in data analysis. So the use of variable or factor. So we use variables to take different values, okay, among respondents. So if we have variable age, we are going to receive a lot of ages from what? Different respondents. So a variable, as used in data analysis, helps us to what? Take different values among respondents. Okay. So in the following question, we were presented with a table. This question, we are presented with a table. So this table is a variable view, okay, of a data file. So we have the names of the variables, their types, their width, their labels, their values, and a measure. Okay, so this one basically look like the SPSS variable view. So we need to provide the correct things that are supposed to be the alphabet allocated from A to Y. I think so, yes. So we have A, B, C, D up to Y. We need to provide the accurate answers that are supposed to be at what? The various alphabets. Okay. So with the variable age underscore 1, before we can give the correct answers for A, B, and C and D, we need to look at the label. So the label says age at last birthday. We agree that your last birthday, okay, will give you a definite value. So your last birthday was last year or maybe this year, the previous month have already passed by, okay. So maybe your birthday is in January and the questionnaire is asking you that age 1 supposed to be your age at last birthday. So if you turned 19 this year January, then the age there will be 19, okay. So it's a numerical value. So the type here is going to be what? Numeric for age 1. And then the width. The width is like the highest size of the highest age you'll be seeing, okay. So you can basically say that, okay, since nobody has grown past 1,000 years, okay, we'll be seeing at most 3-digit number. That person is maybe 100 and over. Okay, so you can basically make it the weight to be what? 3. So we expect maximum of 3 digits over there. Is that clear? Then we move to the value. So value is where we recode our already coded data point, okay, the answers you'll be getting for the respondent. So since you'll be getting different type of numbers from the respondent, we cannot give or recode it over here. So we are going to leave it blank. So value is just going to be dash. And then D is a measure. You'll be receiving different kind of ages from people. So the measure is scale. Okay. We've answered A, B, C, and D. Comment. So A was numeric. B is 3 because we expect at most 3 degree age. And then C will be dash. And then D will be equal to scale. Okay, so we move on to variable 2, age underscore 2. Also, before we can give the answers for E, F, G, and H, we should look at the label. The label says current age. So current age, it means that when your birthday is in, let's say, May, okay, already past May, and at that time you became or you turned 20 years, it means that you are 20 and some other months old. So May, June, July, we are currently in August. So we can say you are 20 and 2 months and then some few days, okay, which is what, 13 days old. So it's numeric and it's continuous. Do you understand? So E also will be numeric. F, that's the width. Okay, so we have years, months, and then uh, F also 3, and then G also giving us dash because we're not going to code, and H giving us scale. Then we move to variable 3, age 3. So looking at age 3, the label is what? Age group. Age group. So it means that maybe the question will give you multiple choice answers in which age groups we have 15 years to maybe 25 years as one group, 26 to 35 years, another group, 36 to 45, and so on. So our I, okay, since it is categorized, okay, and the age group, you have the numbers you have attached to the ages will not really play any significant role, but we are going to code them. Okay, so the numbers there, we have numeric, and then J, which is the value, will be the coding you did. Okay, so maybe if your range were 15 years to 25 years, you coded it as 1. That's where you're going to do the coding again. So you say maybe 1 equals, you have the range, let's say 15 to 25 years. Okay, so the 1 there you have for the width for age 3 is the group that respondent took. Okay, so you can give an example that you're going to recode it back to the original age group, and your K is going to be, remember measure, we have nominal, scale, and then ordinal. So this is going to be nominal. Okay, we move on to, let me see. Okay, we continue over here. We have L. Okay, so L is gender 4, and that we have numeric, and the label is gender. Okay, so your gender, we expect either male or female, but in this case, the type is numeric. So it gives you a clue that it was coded. So if it was coded, we can decide that then it means that the weight will be 1. Since it's either a male or a female, the weight will be 1. And then M will be where the coding is. So we can code it as what? 1 to be female, and then 2 to be male. Okay, so that's for M. And then N, also the measure is nominal. We move on to O. So for O, we have gender 5. Before we can give O, P, Q, and R, we look at the value, and the value was F to be female and M to be male. So it means O is going to be what? String. And then P, the width, is going to be what? 1, because it's represented by male, which is M, female F, 1. Alright, so Q is going to be our label, and it's also what? Gender. And our R is going to be what? Nominal. SAT level. So S, looking at SAT level row, we have that the label is what? Job satisfaction. And job satisfaction, it was having a value where we have 1 to be not satisfied, 2 to be neutral, and 3 to be what? Satisfied. So the satisfaction level of the respondent. And in this case, since it is a Likert scale, okay, the type is going to be numeric because they assigned the various responses in the Likert scale to 1, 2, and 3. So numeric, we have T to be the what? Width, and it was still 1 because you have 1, 2, and 3. And then U is going to be ordinal. And the last row, we have salary. So salary, the label is basic salary. So we expect to see them typing or giving us, okay, averagely, I take home 3,000 cedis every month. Okay, so if the last row, salary, talks about their basic salary, then the type of value we'll be expecting is also numeric. The width, which is W, will be let's give a maximum of 5, thinking that the highly paid person in Ghana is 99,000 or takes home 99,000 Ghana cedis, okay, which makes it 5 figures. I'm not sure anybody in Ghana takes 6 figures every month, okay. And then we have X to equal to the W basically depend on the kind of salary you're responding to take. You look at the highest value in there, and that will determine the number of figures you put there. So if maybe there's an exceptional person taking 6 figures, your salary weight will be 6. That's basically it. So X is going to be what? Your value. And since you're not going to code them, your value will be empty, and your Y also will be scale because you'll be having series of money, then it's going to have weight. somebody taking 10,000 is higher than somebody taking 5,000. Are you okay? We continue. Difference between field data and experimental data. So as the name implies, field data collected in an environment where events occur without researcher control over all the conditions. Okay, so you are outside observing by yourself, and then you take into consideration whatever is happening, record all the things that are of interest to you as a researcher. And for the case of experimental data, the data is collected under controlled environment, and a researcher induces the effect affecting the object or the things of interest. So for field data, you can also say that it reflects the actual conditions and behaviors, more variability and potential for uncontrolled influences, because we are just letting nature do its work. And for experimental data, we try to I don't know, I'm not saying it's biased though, but we force and control the conditions, okay, to reduce the impact of the external factors. We make sure whatever conditions we want, it is obtained before we collect our data. So we can give typical examples under each. For the experimental data, we can say that we are testing the effect of fertilizer type on plant growth. This is a typical example. So under identical light, water, and soil conditions. Okay. And for field data, you can also say that we are measuring the amount of rainfall in different regions in Ghana. Also, we can observe the traffic flow in major cities in Ghana, say Accra, Tamale, Kumasi. Okay. So in those cases, we do not have control over the external factors causing heavy traffic or light traffic. But for the experimental data, in case you are testing for the effects of fertilizer type on plant growth under identical light, water, and soil conditions, we can make an error or a small discrepancy in the amount of light exposed to various plants being applied to the fertilizer. Okay, so in the experimental data, the researcher is taking charge of whatever case that will cause changes in the results we expect, basically field and experimental data. We move on to the next question. We've been presented with a table. We have been presented with a table. Characteristics of main statistical technique. So we have purpose, example of question, parametric statistic, non-parametric alternative of the parametric statistics, the independent variable, and the dependent variable. All right. So for the purpose, we have exploring relationship and also comparing groups. So under each purpose, we have some questions in which you are supposed to answer them. All right. So you're going to take the answers that are supposed to be written at A, B, up to the last alphabet. Okay. We begin with A. So the example of question under exploring relationship, we have what is the relationship between gender and dropout rates from therapy? So looking at the variable type, gender is categorical, and then dropout rate can be numeric, okay, can also be categorical in some cases. Okay, so saying that it is categorical and then the dropout rate is numeric, we can talk about the parametric test correlation. So uh, correlation, then Pearson correlation, and so on. And for the non-parametric test, which is B, if the dropout rate is categorical, we can use chi-square test. Chi-square test of what? Association. Alright, and the independent variable, which is C, is going to be gender, and then D, dependent variable, we are going to use a dropout. The next question, going for E, that is there a relationship between age and optimism score? Is there a relationship between age and optimism score? So still under exploring relationship, right? So we have age. Age is numeric continuous, okay, and then optimism score 2 is also numeric and also continuous. So you can also use correlation for that, or specifically Pearson's correlation, and then its non-parametric, which is F. You can use a Spearman's rank correlation. Okay, we have G. The independent variable will be the age, and age. The dependent variable is the optimism score. I'm not really confident with the answer for A, but you can search on it and see. Okay, we have I. We're now in a different purpose, comparing groups. So comparing groups, we have, is there a difference in optimism scores for people who are under 35 years, 36 to 49 years, and 50 plus years? So we have optimism score, numeric and continuous, but being compared to a category where you have people under the age 35 years, between the ages 36 and 49, and then 50 plus. So we want the parametric test statistics. We can use ANOVA, okay, and then J, non-parametric, we can use a Whitney U test. And for K, which is an independent variable, that's our age, and then L, we have the optimism scores. Answer the following questions for section B, question 3. What type of variable is question 1 to question 5 respectively in the questionnaire? So the hint, we say state whether it's categorical, continuous, or discrete. Okay. So for question 1, are you a Ghanaian or are you a Ghanaian citizen? So the answers we expect are yes or no. So what type of variable is question 1 to question 5? State whether it's categorical, continuous, or discrete. So in this case, it's categorical. We expect someone to be Ghanaian, others to not Ghanaian. So it is categorical. We move on to the next question. Were you born in Ghana? So the answer we expect is also yes or no, meaning it's also categorical. We move on to question 3. In which country were you born? So we expect to see different responses. Okay, those who are not Ghanaians, you see different countries. Those who are Ghanaians, you see Ghana there. So it means that one is also going to be categorical. Question 4. How long have you lived in Ghana? We have A, less than 5 years, B, between 5 years and 15 years, C, more than 15 years. So it's also categorical. Question 5. In which of the following age groups do you fit? Under 18 years old, 18 to 25 years, 26 to 45 years, 46 to 65 years, and over 65 years, also categorical. Continue with question 4, our last question. So with question 4, we're asked to do some hypothesis testing. Okay, so we have a healthcare consultant wants to compare the patient satisfaction ratings of 2 hospitals. The consultant collects ratings from 20 patients for each of the hospitals. A. Suggest an appropriate hypothesis for this problem. B. Given that the test result is given in table 3, answer the suggested hypothesis. So a healthcare consultant wants to compare the patient satisfaction ratings of 2 hospitals. So we can say hospital A and hospital B. We want to know if there is difference in the ratings of these 2 hospitals. So suggest an appropriate hypothesis. So we can compare the means of the ratings. Okay, so we can use U underscore A to represent hospital A, or mean rating of hospital A, and then U underscore B will be the mean rating of hospital B, right? So our appropriate hypothesis H naught is such that mu A is equal to mu B, and then the alternate hypothesis is such that mu A is not equal to mu B. That's our appropriate hypothesis. So that was question A. Suggest an appropriate hypothesis for this problem. Okay, and then B. Given that the test result is given in table 3, answer the suggested hypothesis in A. I'll briefly show table 3, then we see what we can derive from it. Alright, so this is table 3, and for table 3 we have the t value to be 6.31, the degrees of freedom to be 32, and the p value to be 0.00000. So given that the test result is given to answer the suggested hypothesis, the p value is 0.00000. Okay, so it's less than 0.005. Okay, if it's less than that, what do? We reject the null hypothesis and say that, or conclude that, the mean ratings are not the same. Are you okay? C, state the statistical test used or you will use to analyze the data. So when I was talking about the hypothesis, I was mentioning mu. Okay, so it means that I was basically using the independent sample t-test because we are comparing the mean of one hospital to another hospital. So using the independent sample t-test will be the best one for this question. D, state 2 hypotheses you need to satisfy in order to run the test. So since some independent sample t-test is a parametric test, it needs to conform to the assumptions for parametric test. So 2 hypotheses you need to satisfy is the homogeneity of variance or equal variances across hospitals. Okay, and also normality. If you check for normality and then equality of variance, I think you are good to go to further analyze the data with the independent sample t-test. Thank you, ladies and gentlemen. I hope this video will be helpful in your studies as you prepare for your end of semester. Have a good night.